Alright, so last time we talked about how to solve a how to write an algebraic equation from a sentence. We're now going to use that skill to solve word problems. So Kelly has $1,200 in the bank. She wishes to increase her account total to $3,000 by depositing $50 per week from her paycheck. Write and solve an equation to find how many weeks she needs to reach her goal. So our unknown in this case is how many weeks she needs to be depositing $50 each week to get to her goal of $3,000. So she's starting with $1,200, and she's saving $50 per week, so $50 times X. Our end goal is to get to $3,000. So that's the equation we're going to use to solve for how many weeks she needs to do. So we'll subtract 1,200 from both sides first. So 50x equals 1,800. We divide both sides by 50 to solve for x. And we are going to get, for x, 36. That's how many weeks it's going to take her of saving $50 each week to bring her total in her account from $1,200 to $3,000. So yeah, we need to identify all our different numbers in this problem, where our variable is, and how all of them relate to each other. We're increasing, that's why it's a plus. It's $50 per week, that's why it's 50 times x, and our end goal is 3,000. And we did start with 1,200. So we have 150 Skittles in a bag of candy. You can hold 16 Skittles in one handful. How many handfuls are needed to eat all the Skittles? Word to the wise, please do not try this at home. I don't want you shoving 16 Skittles in your mouth all at once. That will probably end with you choking, and I'm not responsible for that. So do not do that. So she wants to get to 150 Skittles, eating all of them. She can have 16 Skittles in each handful, so I need to multiply 16 by x, number of handfuls we need. There's nothing to add to that, it's just 16x. So to solve, we divide both sides by 16, and we get 9.375 for x. Now, that's what x equals, and if this was only an equation, no word problem, you would be done. But you need to use some logic with your word problems. Decimals are allowed in certain situations. For example, money, you'd be allowed to have a decimal. You're allowed to have cents. You would obviously have to round to the nearest hundredths place if there's more than 2 digits after the decimal. In this case, though, we can't have 0.375 of a handful, so it needs to be a whole number. 9 would be too small because there'd be some Skittles left over. So this means we need to round the entire number up, so there has to be 10 handfuls to eat all these Skittles. Again, 9 is not enough, 10 is plenty. Again, do not do that at home. Tiffany's piggy bank holds quarters, nickels, and dimes. She has 4 more dimes than quarters, and 3 less nickels than quarters. If she has 25 coins, how many of each coin does she have? Now, in this case, we have more than one variable. Now, this is not a system of equation. We don't have 3 equations to solve for these 3 variables. So what I must do is, I need to find a way to relate each one of these unknown quantities, quarters, nickels, and dimes, to one of those 3 variables so I can solve my single equation I have, that they all have to add up, quarters, nickels, and dimes, to 25. Well, the problem tells us that she has 4 more dimes than quarters. So if I take the number of quarters and add 4 to it, that will give me the number of dimes. She has 3 less nickels than quarters. So if I were to take the number of quarters and subtract it by 3, I would get the number of nickels. And finally, Q is just, quarters would just be Q. So if I plug these expressions, all in relation to Q, back into my original problem, I only have one variable now. I have Q plus Q minus 3 plus Q plus 4 equals 125. Now that I have one variable, I can solve. Now again, you got to use some logic. If you get a decimal in the situation, that tells you did something wrong. Maybe you wrote 3 minus Q instead. Remember, it's 3 less than, so we have to take 3 from the number of quarters, or something else went wrong. So when I combine like terms, I get 3Q plus 1 equals 25. Subtract 1 from both sides. 3Q equals 24. Now divide both sides by 3. I do get a whole number, 8. Now again, I'm not done. I need to know how many of each coin does she have. So I plug the 8 back in. We have 8 quarters. 8 minus 3 is 5 nickels. 8 plus 4 is 12 dimes. That is my answer. 8 quarters, 5 nickels, 12 dimes. And if you add all those numbers up, you'll get back to 25, which is how many coins she has. Now, some word problems are just simply a sentence, similar to what we did last time, where now they ask you to solve for the number that they don't know. We have 12 decreased by twice number equals negative 34. Well, there's my equal sign. It says it equals. To the left side of that, it's 12 decreased by twice a number. Since it's decreased by subtraction, I keep the order it says. Had it said subtracted from, we'd switch the order. So it's 12 minus 2x equals negative 34. My only part on the right-hand side. We now have this simple linear equation to solve. So I subtract 12 from both sides. Negative 2x equals a negative 46. When I divide both sides by negative 2, we get x equals 23. Boom, we're done. In this case, we got a whole number, but this would be a case we're allowed to have a decimal. Because a number could be anything. It could be a whole number, it could be a decimal, it could be a fraction, it could be a negative number. It doesn't matter, as long as it's a number. Now, in this case, we have to get whole numbers. It says find 4 consecutive integers with the sum of negative 142. They have to be integers. So whenever I solve for x, in this case, it better be a whole number. So my first integer is x. Well, if it's consecutive, for example, if my first number is 4, we'd go to 5 next, and then 6, and then 7. So each one of these times, to go from 4 to 5, I increase by 1, so x plus 1. To go from 4 to 6, I have to increase by 2. And to go from 4 to 7, I must increase by 3. So if when it says consecutive integers, you're always going to take your first number as x, and then just add 1 to each new integer until you get to how many you need. We need 4, that's why we stopped here at x plus 3. We had 4 consecutive integers. It says the sum, so we must add them all together. So x plus 1 plus x plus 2 plus x plus 3 must equal negative 142. And again, so we're talking about integers. If we don't get a whole number for x, it tells us we did something wrong. When I combine, I get 4x plus 6 equals negative 142. We subtract by 6. 4x equals a negative 148. I divide both sides by 4. Then we get x to equal a negative 37. It's a whole number, so that's good. Negative doesn't matter. It's as long as it's a whole number. Now, they don't want x, they want the 4 consecutive integers. So we have to plug x back in, so negative 37, negative 36, negative 35, and negative 34. These are my 4 consecutive integers that when you add them up, you get negative 142. So one more. Consecutive odd integers, same concept. We start with x. But now we're not going to add 1 to it. For example, if my first odd integer was 3, next one is 5, next one is 7, and so on. To go from 3 to 5, I must add 2. So we're going to have plus 2. To go from 3 to 7, I have to add 4. So it's x plus 4. So whether they're consecutive odd or consecutive even integers, you're going to start with x, and each integer after that, you're going to add 2 to it. So plus 2, plus 4, plus 6, plus 8, so on until you get to how many integers you need. So again, it's a sum, so we're going to add them up. X plus 2 plus x plus 4 equals 141. We want to solve for x. 2 things to keep in mind. Again, x has to be an integer, so if you get a decimal, you did it wrong. And it has to be a certain type of integer. It has to be odd. So if you get an even number when you solve, sure, it's an integer, but it's not an odd one. So again, little logic tells you made a mistake. So when I combine like terms, we get 3x plus 6 equals 141. Subtract 6 from both sides. 3x equals 135. We divide both sides by 3. X will equal 45. It's an integer and it's odd, so we did it right. So I plug it back in because they want the 3 consecutive odd integers. X is 45, next is 47, and next is 49. Those represent my 3 consecutive odd integers that, when I add them together, will give me 141. You're going to use the similar logic, obviously, said even integers. If it was 5 of them, again, you just keep on going. Always increasing by 2 for each integer. So those are the word problems I have for you right here. There are obviously an infinite number of word problems we could work through, but we don't have that much time to do that many different examples. The key is to do what we talked about here. Find the equation that works based off the situation, using the different keywords in the word problem itself, and all the information it gives you, and then solve for your variable. If you're getting decimals, make sure it makes sense. If we're talking about integers, it should not be a decimal. If we're talking about handfuls like our Skittles, we obviously cannot have a decimal of a handful, so you need to round up to the nearest whole number. Next one up. And if there's a decimal, we're talking about money, that's allowed. Just make sure you round to the nearest hundredths place. Alright, so I will see you next time when we talk about how to solve absolute value equations.